Hello, CSEC scholars. Welcome to another live CSEC class. Today we're going to be doing some trigonometry and we're going to be calculating missing angles. The last trig class that we had, we looked at the different types of angles, and prior to that we looked at angles in a triangle. So this was all leading up to this point. If you need a refresher on that, so you can look at those videos that we did last week. If you need to remind yourself, what are the special angles? How do we identify them? What are the measurements? That kind of thing. You can always go and check out those videos. All right. If you're up to speed with that, just hang tight and we're going to dive into some calculating missing angles. So we're going to start with some really basic stuff. So let's say we have a triangle. Oh my, that's a triangle. Let's pretend that there's a point at somewhere up there. And this angle, let's say this angle is 82 degrees. Remember, angles are measured in degrees. So let's say that's 82. And let's say this, not drawn to scale, of course not. But of course not. This is 45. And we want this one. We want to know what is the degree of measurement for this angle here. We're calling this angle X. No, so we know this one up here is 82 degrees. And we know this one here is 45 degrees. So how do we find this one? So let me hear what my scholars are saying. Let me see if they remember what we talked about in the last trig class. How would we find that missing angle, scholars? Type your answer and tell me. We know, so it's a triangle. We know two of the angles. So Trevor is saying add them up. Add them up. So, okay. So Trevor is saying add them up. And then, so he means add the two angles that we know already, add those two, and then subtract them from 180. Why 180, Trevor? Why not subtract them from 100? Or why not subtract them from 360? Why is it 180 that we must subtract them from? So one of the things we remember from when we talked about angles in a triangle is that all three angles in a triangle must add up to 180 degrees. All right. So Legende says because all angles are supposed to add up to 180, and that's correct. In the triangle, all three angles, and Trevor is saying the same thing. Trevor, you're right. So since we know that all three angles must add to 180, and we know two of the angles, So Trevor is correct. We add the two that we know already. So we add up these two and we get 127 degrees. And then we are going to subtract that from us. The final answer is, and we have to put our units, 53 degrees. All right, here x is equal to 53 degrees. All right, again, we have a triangle. We want this one, this is y. We know this one is 70 degrees. And we know that one is 53 degrees. So we know two of the angles. We want to find the third angle. For this one, we add the two angles that we know already. So 53 plus the 70, that's 123 degrees, and we're going to subtract that from 180 degrees. And that is going to give us 57 degrees. So angle Y, which was the missing angle, we have calculated it. So remember now, if you're given two of the angles in a triangle, since you know that all three of them must add up to 180 degrees, if you know two of them, add those two together and subtract it from 180 and you'll get the missing one. All right, so let's go. Vamos amigos, let's go. So we are going to pretend that this is a right angle triangle. Okay. We are told that this angle is 48 degrees and we want this one. So let's call that angle P. So let me hear from my scholars, my brilliant scholars. How are we going to find angle P? So look at the triangle. It's a right angle triangle. We're pretending, and we see that little box in the corner. We know it's a right angle triangle. So one of the angles is 48 degrees. We want to know the other one. Let me know what I'm supposed to do. So Ngozi says 180 degrees minus 48 degrees. Najara says 90 degrees plus 48 degrees. Is that all I need to do, Najaro? And where does that 90 come from? I don't see any 90 up there. I didn't see them put any 90 there. I just see 48 degrees. So listen now. Okay, so Ngozi says 132 minus 48. Ngozi, I would love for you to tell me where that 132 appeared from. Jamani says add 90 and 48 degrees and subtract it from 180. And the little box represents the 90. All right, thank you, Jamani. I think that's what Najaro started off doing, but then he left me cold. He didn't tell me anything further. So Jamani is correct. Even though they did not put a 90 anywhere there, we know this is at 90 degrees because we see the box. It's a right angle. We know it's 90 degrees. So we can put it, or we don't even have to put it. We just know. Once it's to the box, it's 90 degrees. So it's just as if we're saying we know two of the angles already. We do. We know two of the angles. One of them is 90. The other one is 48. Nobody has to tell us that this is 90. We know it. So we add those up. And then, just like with the two triangles before, we take that from 180 because we know all three angles must add up to 180. All right, so that's 7, and that leave back 2. So angle P is 42 degrees. Yeah, right, angle P is 42 degrees. Suppose we're given this one. Suppose it looks like that. And you know I have a difficulty drawing straight lines, so don't hold it against me. We are pretending that the lines are perfectly straight. Use your imagination. So that's 25 degrees. And we want to know what is W. Hey, you come at the bad time, man. Yeah, circle back. But what time? About 3. Mm-hmm. No, I'm up on a live class. That's what I'm Pine melon. What's yeah, that too. Circle my back here. Sorry about that, guys. My fruit vendor is passing and I couldn't let him pass without placing my orders because I have to get my fruits. All right, so here we go now. So again, we know this is a 90 degree, right? We know this is a 90 degree angle. They didn't tell us, but we know because once you see the box, right? And this is 25 degrees and we want W. So again, we're going to add 90 and 25. And we're going to get 115 degrees. Since all three angles must add up to 180, we're going to take that away. So we're going left with that going to be 5, that going to be 6. So angle W is 65 degrees. Let me see what you would say for this one now. Let me see what you're going to say for this one. All right, so this is it. Perfectly straight lines. What is this angle here? Let me hear what my scholars have to say for this one. How do I find angle X? Yes, Gozi says she love our fruits. Gozi, I couldn't make the fruit van pass and no place my order for my pine and my melon and my orange and them something there. So I'm going to circle my back when the class done. When the class done, I'm going to come back. All right, so what do you say, guys? How do I find X? How do I find X? So Aiden is saying 180 minus 90. And Najara is saying divide 90 by 2. Cash mark said 45 degrees. It sounds like you know something, you know. It sounds like you know things, you know. And Trevor said 180 minus 90, then divide by 2. All right, sound like you know on stuff. Okay, so I couldn't trick you with that one. All right. So what the scholars are saying is that, all right, we know this is 90. But how you got, wait there. Tell me how you know that you must divide by 2. You have to tell me that part. How you know that you're supposed to divide by 2? Why are you going to divide by 2? Legende, you can't, it's not that you're going to take 180 from 90. It's the other way around. 180 minus 90. Trevor, tell me why you're dividing by 2. I'm not letting you guys off so easy. You have to explain everything. Show me say you really know your stuff and you're not guessing. But Cashmark is saying 90 plus 45 equals 135, and then 180 minus 135 equals 45. But how where the first 45 come from? Trevor said because both angles are missing, that's why it's logical to divide. But how do you know that the two angles that are missing are equal angles? There's something on the triangle there that's telling you that the two missing angles are equal. What is it? There's a clue there. What's the clue? So Najara said the strokes. The strokes that are on the lines mean that the two angles are equal. All right. So what he's talking about are these. Anywhere you see the same strokes on lines, those two lines are equal. So if these two lines are equal, that means these two angles are equal. That means what kind of triangle are we dealing with here? Let me see if them know what kind of triangle this is. Since the strokes tell us that those two lines are equal, and so we know the two base angles are equal, what kind of triangle is it we're dealing with? What's the name of this triangle? No goes is not equilateral. It's not equilateral. Equilateral would have 3 equal sides and 3 equal angles. This one has 2 sides that are equal and 1 side that's not. All right, so Cashmark says isosceles, and that's correct. It is an isosceles triangle. It has 2 angles that are equal and 1 that is not. And as a matter of fact, this is a special isosceles triangle, which is a right isosceles. It's a right angle triangle, and it's also an isosceles triangle. So it has a 90-degree angle, which makes it a right angle triangle, and it has 2 equal angles, which makes it isosceles. So this is 90. So if we take that 90, as my scholars said, because they know their stuff, so these two must add up to 90, and since they are equal, we are going to divide 90 by 2. So each of those angles is 45 degrees. X is 45 degrees, and this angle here, even though they didn't ask us for it, but we know. So we can even show off and tell them, said that is 45 too. Right? We can, yeah, because they are equal. So let me see what you would do for this one now. Suppose I have a triangle that look like that. and it looks something like that. And they want to know this angle here, angle A. Let me hear what you guys say. How would I find angle A? So look at it carefully. They want angle A. How am I going to find angle A? Yes, cash mark, you got it right. Very. Okay, so look at this now, guys. What is the measurement of angle A? Aiden is saying 45 plus 45 plus 45. If you add those up, Aiden, do you get 180 degrees? Cash mark say each stroke would be 30 degrees. All right, so Trevor is saying it's an equilateral triangle. That is correct. So what is angle A? All right, so Trevor says divide 180 by 3. Since all the angles must add up to 180, and these three angles here are equal because, see, the strokes tell us that the three sides are equal. So the three angles are equal, you see? Right goes it's an equilateral triangle. And in an equilateral triangle, the angles are always. So Sika Mark is saying 60 degrees, always. The equilateral triangle never changes its angles. It has three equal sides and three equal angles. So 180 divided by 3 is 60. The angles in an equilateral triangle, each of them is always 60 degrees, never changes. These strokes tell us the three lines are equal. So these three angles are also equal. 60 degrees, 60 degrees, 60 degrees. All right, so we're moving along. All right, so tell me. So I'm going to give you two missing angles. This one is going to be missing. This one is going to be missing. This one is 82 degrees. And this one here is 125 degrees. All right, so we need to find X, we need to find Y. So this is a little more complicated. Whichever one you want to find first, tell me how you're going to find it. Yes, cash mark. For the CSEC math, you can use your calculator if you think you need to. All right, so whether you want to find X first or you want to find Y first, but you have to go tell me now how you find it. Don't just tell me add what and add what. What are you finding? Which one you finding, the X or the Y? I see people telling me add 82 and the 125 to find what? To find X? People telling me take away 125 from 82. That don't even make sense. That will give me a negative angle. Oh, so you change it, Najaro. So 125 minus 82. What are you finding? X or Y? And why do I subtract to find that angle? It kind of sounds like you guys grasping at straws, though. I want someone to tell me definitively, Miss, do this because. Remember, we did the class last week, types of angles and how you identify them and what they measure. So tell me, Miss, you are to do this, this, because that. So let's say we're finding X first. Who can see the triangle? Legendary can see the triangle? All right, so Zion says to find X, subtract 82 from 125. Why, Zion? What's the relationship between X and 125 and 82? Why do I subtract the 82? All right, let me help you guys out for this one. Let me remind you what we said about the exterior angles and angles on a straight line as well. So these two angles are on a straight line. Angles on a straight line add up to 180 degrees. So since we know this one, we can take it from 180 to find this one. So if we're finding X first, that's what we would do. Take the 125 from the full 180. These angles must add up to 180. They're on a straight line. And we would get this. Or we could use the rule about the exterior angle. In a triangle that's set up like this, where you have an exterior angle, so this angle on the outside, this angle is equal to the sum of these two interior opposite angles. So the external angle or the exterior angle is equal to the sum of the opposite interior angles, these two. So since these two add up to give this, we can find y by subtracting the 82 from the 125. And if we didn't find x yet, when we find y, we could add these two and take it from 180 to find x. Let's do it the easiest way. So using those two rules, for x and 125 are on a straight line. Angles on a straight line add to 180. So to find x, I am going to subtract the 125 from 180. And that is going to give me that's going to give me 55 degrees. So x is 55 degrees. For y, the exterior angle is equal to the sum of the two opposite interior angles. So 82 plus y would give 125. So y will be equal to 125 minus 82. And that's going to give 43. So y is 43 degrees. Okay, so remember that angles on a straight line add up to 180 degrees. The exterior angle is equal to the sum of the two opposite interior angles. So here we go again. All right, so tell me W and X now. How do I find angle W? And how do I find angle X? Let me hear some ideas. So based on what we just did, how do we find W, and how do we find X? So Cashmark said he got X right. Okay. So what is this X now in this diagram? There are a number of ways we can use to find X for this one. What's the most direct way we can find X here? Or if you find W first, because W is also easy to find, just one step. Once you know W, you can find X. So Cashmark is saying X is 79. So tell us how you got 79. Okay, so Dinsmore says W is equal to the two interior angles, yes. But the two opposite interior angles, not the two that are given there now. So W would be equal to the 73 plus X, not the 73 plus 28. Zion says to find X, you add the 73 and the 28. That equals to 101. Then you subtract that from 180 and that equals to 79. That's correct. That is correct. So let's do that. So Zion is saying we're focusing on the triangle now. We'll come to this later. If we focus on the triangle, we know two of the angles, so the other one must be the two, add up the two that we know. (73 plus 28, right? And then we take that from 180. 79. So X is 79 degrees. All right, so far so good, right? So far so good. So now what is W? What is W now? Cashmark, where the 152 come from? We know that X is 79 degrees. Right. So Zion says to get W, we add the 73 and the 79, and that equals 152 degrees. Oh, okay. So Cashmark is saying another way to do it is to take the 28 from 180 and you get 100, and it's 52 or 6 is 52. Okay, 152 degrees. Okay, so right. So there are two ways we can find W. We know that W is the sum of these two opposite interior angles, and since we just found X, we could find W by adding the 73 and the 79. That's one way, and we would get 152 degrees. Or we could focus here. W and the 28, they are on a straight line. Angles on a straight line add up to 180. So we could take the 28 from the 180. This is another way to find W. Remember, you know, this is maths. You can have many, many ways. Several roads can take you home. So see, we get the 152 there. So we want to find W. We know that the exterior angle is the sum of the two opposite interior angles. These two, not these two or these two, the opposite interior angles. And we just found one of them is 79, and we know one of them is 73. So we can add them up and we get W. Or we can focus here. Angles on a straight line add up to 180 degrees. So we know one of them, take it from 180 and we'll get the other one. All right, so let's move on. Let's move on and on and on. So let's say, so we have a regular scalene triangle. Scalene triangle. In a scalene triangle, we have all sides and angles are different. But let's say we said as 5x. This is 2x. So throwing in some algebra at you, and this is x. And suppose you're asked to find the degree for each of those angles. How many degrees is each of those angles? How would we approach that question? Cashmark says it looks like an equilateral. Even if it looks like one, just looking at the angles tell us it cannot be. Because in the equilateral triangle, all three angles must be equal. They must be the same thing. So you'd have to see x, 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 or 2x, 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 or 5x, 5x, 5x. Whatever is in one would be in the other two. But we have three different angles there. One is x, one is 2x, one is 5x. So it cannot be an equilateral. It's a scalene triangle. So Cashmark said 5 times 2 is 10. So what is 10 degrees? So all of them would be 10 degrees. Would all of them be 10 degrees? Let me hear some more ideas. How are we going to approach this question? Imani, John, any ideas? It's three different angles. We want to find what's each of them. Yes, Imani, we have to find x. So what we're going to do? All right, Zion says to find x, we add the 5x plus 2x plus x, and that will give 8x. And then we divide 180 by 8 to get x, and that will be equal to 22.5. Okay, so that's an idea. And Imani is saying the same thing. So Imani just typed the same thing Zion said. So we know all of them must add up to 180. So let's do a little algebra then. So the 5x plus the 2x plus the x must be equal to 180 degrees. 5x plus 2x plus x, that's 8x. So 8 times what? Give 180. So we're going to divide 180 by 8. And we'll get the value of x. So 8 into 18, 2 times. Remainder 2, 8 into 20, 2 times. Remainder 4, 8 into 40, 5 times. So 22.5. So this is just x. This one is 22.5. To get this one, so this one over here is 22.5 degrees. To get this one, this is 2x. So we'll have to multiply the 22.5 times 2. Because remember, the 22.5 is just x. 2 2's 4 and 1 5 and 2 2's 4. All right, so this is 22.5. This is 45 degrees. And to get 5x now, this angle, we'd multiply the 22.5 by 5. Because it's a 5x. 5 5's 25. 5 2's 10 and 2 12. 5 2's 10 and 1 11. So this big angle here is 112.5 degrees. So this angle is 22.5 degrees. This one is 45 degrees. And this one is 112.5 degrees. So now that you know these things, let me give you one similar to that. Similar and with a little twist as well. All right. So I'm going to want y. This is 4x. This is 3x. And this is 3x. Give me all these three angles and also tell me why. What this angle is. Angle y. Let me hear some ideas. I want each of those three angles. Yes, you can have decimal as your answer, cash mark, or fraction. Yes, you can. All right, so tell me what each of those angles would be based on the knowledge you just gathered. Based on the knowledge you just gathered. So talk to me now. Talk to me. What are the three interior angles? What would be 45? Yeah, you can't just say it would be 45. We have 4 missing angles up there. We have 4 missing angles. So what would be 45? Is it the angle that says 4x, the angles that say 3x, or the angle that say y? Which one are you talking about? So cash mark is saying is he would divide 180 by 4. But why? Okay, so Imani says to find x, 3x plus x. All right, so 3x plus x. So after we find x, then 3x plus 3x will give y. Yeah, that's one way we could find y after we find x. So find x then. So Zion says To get x, we add the 3x plus the 3x plus 4x, and that is 10x. So then we divide 180 by 10, and we get each angle is 18 degrees. You know, that's not the end of it, Zion, so tell me the rest. Tell me the rest of the story. That's not the whole story. Sajarta says that's what he did. What's the rest of the story, Zion? It not done yet. Okay. So x would be 18. But what would be the measurement for the angles? That just give us x, you know. How we're going to find the angles themselves. So let's do that part first, what Zion said. So he's saying, we know that the angles in the triangle, they must add up to 180 degrees. So from our knowledge of algebra, 3x plus 3x plus 4x. So 3x plus 3x plus 4x. All of those angles must add up to 180 because they are angles in a triangle. And Zion is saying when we add those, when we simplify this and combine the like terms, add the x's, 3 plus 3 plus 4, that gives 10x. So if 10x is 180, then x is 180 divided by 10, which is 18 degrees. But that's just x. None of the angles are not just x. This is 4x. So to find this angle, it will be 18 times 4, which is 72 degrees. To find this angle is 18 times 3, because it's 3x. And that is what? 54 degrees. This angle is also 18 times 3, which is 54. It's the same as this one. So that's also 54. And like Imani said, you know, once we find x, we automatically find y, because these two angles add up to give the exterior angle. Or once we know this angle, we can take it from 180 and find this one. So there are two ways we could find y after we find x. Add the 54 plus 54. So y is 54 plus 54, which is 108 degrees. So y is 108. Or we could take the 72 from 180. So that's or. It's another way of working it. And that will give us 108, same way, right? Two ways to find y. We can take this from 180 to get this, or we can add these two to get that. Either way, we end up with our answer. All right, so how you guys feeling about what we've done so far? We have a couple more to go. Tell me how you've been processing this. Legende, I don't know how you can see the board. Other students, are you having difficulty seeing the board? All right. We're going to do maybe 4 more. Let's do 4 more quickly. Everybody else can see the board, Legende. So I don't know, something wrong with your device. All right. So we're going to do 4 more. And you know that next week we're going to have to do some more of this, right? Practice makes perfect. So let's do 4 more, take us down to the end of this session. So now let's deal with some angles on a straight line. You know I can't draw a straight line, so don't say nothing. All right, so that's X. That's X. That's 60 degrees. That's 28 degrees. All right, how would we find angle X? How are we going to find angle X? Talk quick, time going. Add up what, Trevor? Add 28 and 60. And then what? Then subtract from 180 since it's a straight line. Okay, so far so good, Trevor. Yeah. And then what? Something else needs to be done, Trevor. Ah, divide by 2. Why are we dividing by 2? Why do we divide that final answer by 2 to get the final answer? So Zion says we add the 60 and the 28, which gives 88. Then we subtract that from 180 to get 92. Then divide by 2 and we get 46, right? So just like what Trevor says. And Trevor says we're dividing by 2. Trevor, you're not telling me why you divide by 2. Zion, why do we divide by 2? The two angles that are missing are equal. Okay. So Zion and Trevor said it real nice. So we have 4 angles and they are all sitting on a straight line. This is the straight line they're sitting on. And we know that angles of course, we are pretending it's straight because I cannot draw straight lines on this thing. My mouse will not behave. So we are pretending it's straight, and there are 4 angles sitting on this straight line. Angles on a straight line add up to 180 degrees. Therefore, since we know 2 of them, all right, so Trevor and Zion said, add the 2 that we know. Put the 2 that we know together, and that gave us 88. And since we know they are on a straight line, take it away from 180 to see how much leave back. So when we take that away from the 180, we're left with 92. So these 2 missing angles add up to 92. And since they are the same angles, X and X, that is why we're going to divide the 92 by 2, because the 2 missing angles are the same. They're equal. So that is what? 46. So Trevor and Zion came to the rescue. X is 46 degrees. All right, 3 more to go. And next week we're going to do some more. All right, so we have a straight line. And we have a straight line that way. And we have something will look like that. This angle is missing. We want, and this angle is 65 degrees. And down here, so now, this is why, this is why, this is why. All right. All right then. So, how do I find x? And how do I find y? Remember, we're pretending these are straight lines. How do I find x? How do I find y? Let me see the ideas coming in. Come on, come on, come on, come on. Ideas. Ideas, ideas, ideas. What say you guys? All right, so that's a start. Trevor, you're saying the box represents 90, yeah? That's a start. Okay. So far, so good. What else? Okay, so the box represents 90 degrees. Da da dee da da da. Najaro says add the 90 and the 65. Okay, that could work. That could work. Okay. So Trevor saying add them up too, and he got 155. That could work. What else? So what you finding first, x or y? All right. So Trevor said subtract them from 180. All right. So we know Zion are going to come with theme long explanation, which I love. I love when you explain. All right. So Zion says to find x, we add the 90 and the 65 and we get 155. Then we subtract that from 180 and that equals to 25. And that's for x. And to find y, we divide 180 by 3. Brilliant, Zion. Brilliant. And that is 60 degrees. Excellent. And I know Trevor and who else was it? Somebody else. Trevor, let me go back up and see. Was it Najaro? Yeah. Trevor and Najaro, they were on the right track, but not as fast as Zion. All right, so this is correct. So we can focus on the two straight lines in the picture, right? Okay, so see Trevor got his 25 there. Sajarta says he got 25. All right. Trevor, you're saying Zion is too quick. Him always tell the answer. So look now, what we're saying is this. What these guys are saying is, so we're going to focus on this straight line first. This one coming down, right? Remember, we're pretend it's straight. So this line, so these three angles are on that straight line. So these three angles must add up to 180. We know this is 90. That's a 90-degree angle. We know that's 65. So Zion said, add the 90 and the 65. That gives us 155. And take it from the 85 and you get x. Because remember, the three of them are on the straight line. They must add up to 180. So x is 180 minus the 155. And that gives us 25. Why am I writing 2 there? So that gives us 25 degrees. So that's x, right? Y now, so focusing over here now, these 3 angles are on a straight line as well. They're on the same straight line over this side. So they're on a straight line. They must add to 180, and each of them is the same. So 3y give 180. So y is 180 divided by 3, which is 60 degrees. All right. So x is 25 degrees. Each of these y's is 60 degrees. If we were to add up all of them, we would get 360 degrees, because all of them make angles in a circle, right? Or a complete rotation angle. So let's do 2 more, and the 2 that we're going to do have to do with the circle. Now, if we can't draw a straight line, you know that the circle no worse can draw. So we're going to pretend. So that is a circle. All right, so let's say now we have that and that, okay? So we want this angle here, x. This angle is 100 and call it 100 degrees. That's 100 degrees. This angle is 56 degrees. This angle is 125. Not drawn to scale, right, guys? You know it's not drawn to scale. So 56 degrees, 100 degrees, 125 degrees. What is x? How we're going to work out x? So what you guys saying? Zion is too fast. Him always I get the answer them too fast. How do we find angle x there now? So Trevor says add them all up and subtract from 360. Yes, that's what we do. That's correct, Trevor. So see, you beat Zion to it this time. So we know that these are angles in a circle. So we know they must add up to not 180 degrees time, 360 degrees. Angles in a circle add up to 360 degrees. So we know 3 of the angles. So add them up. The 125, the 100, and the 56. Add them up. All right, so that's gonna give what? 281 degrees, and take it from the 360 to find x. Take it away from 360. So that going to give that, and that going to give 9, and that going to give 7. So x is 79 degrees. So this time we're dealing with the circle. Remember, angle in a circle add up to 360 degrees. All right, so since Zion answer finally come in, because you know it have to take a little time to type out in things, right? So to find, we add the 100 plus 56 plus 125, and that gives 281. Then you subtract that from 360 and get 79. All right, yeah. So Trevor got the 79, Zion got the 79. I'm not hearing from some of the scholars. Remember, you must participate so that you can know, ask questions, your answer if you are track, if you're understanding it. That's how you're going to know, when you participate. So we have one last one to do today. Next week, we're going to do another batch of finding missing angles. So this one again has to do with the circle. All right, so again, we draw our circle. Okay, we draw our circle. And so that's 2x. That's 2x. That's 5x. That's 6x. And that's 3x. So calculate each of those angles for me. Tell me the degree measurement for each of these 5 angles. This is the last question for this session. I want to know the degree measurement for each of those 5 angles. Based on our knowledge and all we have gathered so far today, based on our knowledge of the circle, angles in a circle, tell me how I'm going to find each of those angles. So Trevor says add them up. Add them up, you get 18. Do I get 18 or 18x? Okay, so Trevor corrected himself there. All right. So Trevor says we add all these terms and we get 18x. Then what? And Ngozi said these last few ones are pretty challenging. We're going to do some more next week, and the more you do them, the easier they'll seem to you. Divide what, Trevor? Are you dividing it by 180? You sure that's what you're doing? Okay, you divide the 180 by 18. All right. So now we're talking. So Trevor said we add all of these. So we're doing some algebra now in the mix, we mix, because remember the different sections of maths, you can incorporate them. So even though we're doing trig and geometry, we can incorporate the algebra. As a matter of fact, I think algebra is that topic that crosses over into every other topic. Algebra is my favorite topic in math, and I think it just finds a way to cross over into everything, because you're always trying to find an unknown thing, and you can always represent that by a variable, and it's algebra that you're going into, right? So all of these go to add up to, I see what Trevor did wrong. Hold on, Trevor, you did something wrong. I'm just realizing what you did. Trevor, look back what you did. Trevor did something wrong. Who can tell me what he did wrong? All right, since I come here now with film thing. Trevor, say get left right now, because you did some wrong. So let me see what Zion said. So add the 2x plus 2x plus 5x plus 6x plus 3x, and that gives 18x. And you divide the 360 by 18. So where you go wrong, Trevor? You divided 180. Remember, these angles in a circle. They don't add 180, they add up to 360 degrees. So the 18x gives 360 degrees. Therefore, each value of x is 360 divided by 18, not 180 divided by 18. Okay? So the answer is what? The x is 20 degrees, just x. We don't find them yet, no. We just find x. So we have to go now and substitute 20 where x is for each of these. All right? So thank you, Zion. You completed it. Trevor started it, and it was going good until he made that little mistake there. Well, actually, it's a big mistake. Not 180 degrees, 360. So this angle here would be 5 times the 20, because x is 20 degrees. So that would give 100 degrees here. This would be 6 times the 20. And that would give 120 degrees here. This would give 3 times the 20. And that would be 60 degrees. This would give 2 times 20, which is 40 degrees. And this one is the same. So this is also 40 degrees. So, when we add up all of them, we should get the 360 now. So let's check it. If we add the 60 and the 240s, that's 80. And the 100. If we add those up, so 8 and 2, 10 and 6, 16, carry the 1. So we get back the 360 there. See? When we add up all of these degrees, all of the angles, we should get back the full 360. All right, so we did a lot, and there are so many more ways to look. Oh, Trevor said he forgot. Okay, that's fine, Trevor. And that's why we're doing this, all of this practice, so that, the more we do it, the more we'll remember. We're dealing with triangles, 180 degrees. We're dealing with angles on a straight line, 180 degrees. We're dealing with the quadrilaterals, 360 degrees. We're dealing with the circle, 360 degrees, and so on, right? So next week, when we're doing trig/geometry again, we're going to look at some more examples and find the missing angles in these shapes. So that's it for this session on calculating missing angles.